Autocomplete embarrasses your product. We'll make it fast, clean, and relevant. By the end, you will clearly know when Edge Ngrams win, when Search as You Type wins, and how to run both from Python so suggestions feel instant and useful. I'm Professor Pi, teaching Search and IR with simple Python. Autocomplete is a system problem. Users type a few letters and expect a correct suggestion in a blink. Bad suggestions or slow responses kill conversions. People reach for Elasticsearch because it handles indexing, analysis, and fast query scoring at scale. Edge Ngrams and Search as You Type are two practical ways to build autocomplete inside Elasticsearch. Edge Ngrams bake partial tokens into the index so short prefixes match fast. Search as You Type uses a field type built for multi-length matching and tries to balance recall and quality. Success looks like low latency and relevant first three suggestions on real traffic. At a high level, Edge Ngrams expand your stored tokens so a prefix match becomes a full text match. Search as You Type stores several analyzed subfields that let Elasticsearch match prefixes at different granularities and combine those scores intelligently. Edge Ngrams tend to be simpler and faster for short prefixes, but can bloat the index and overmatch. Search as You Type is more compact and often gives cleaner ordering for multi-word queries, but it can be slightly more complex to tune. We will build a tiny local demo. The code will open a client, create an index that holds two different field styles, index a handful of example names, and then run the two query types plus a blended query. This keeps the comparison concrete and makes the trade-offs visible before you scale anything up. Now we'll open a Python client and prepare a tiny list of names for testing. This snippet connects to Elasticsearch and prepares toy names. It shows making a Python Elasticsearch client pointed at your cluster, and then creating a short in-memory list of name documents to index. The top of the snippet opens the client and checks the cluster health so you know the connection works. After that, it builds a small iterable of dictionaries where each dictionary represents one document with an identifier and a text field called name. The play here is to make reproducible tiny data so we can watch how Edge Ngram and Search as You Type behave on the same inputs without any extra noise. Next, we'll create a single index that contains both an Edge Ngram mapping and a Search as You Type mapping for side-by-side comparison. This snippet creates one Elasticsearch index for both approaches. It defines analysis settings and a mapping where one field uses an Edge Ngram analyzer and another field uses the Search as You Type field type. In the settings, you see the analyzer definition, which includes an Edge Ngram tokenizer and a usual lowercase filter to normalize input. In the mapping, you will find an Edge Ngram text field and a Search as You Type field side by side, so the same document has both representations. The core idea is to index once and compare queries against the two fields with identical source content, so the comparison is apples to apples. Next, we'll index those names and try querying the Edge Ngram field with a prefix style search. This snippet indexes docs and queries the Edge Ngram field. The first part of the snippet takes the toy list and sends bulk index requests so each name lands in the index with both fields populated. After indexing, it runs a match or prefix style query against the Edge Ngram field, designed to find documents that match the typed prefix. The explanation walks top to bottom: bulk indexing, refresh to make docs searchable, then a simple query that Elasticsearch scores using full text match on the generated ngrams. If you tune the ngram size in the mapping, you change how early a prefix will match and how many false positives you may get. Next, We'll use the Search As You Type field and a Boolean prefix query to see how that behavior differs. This snippet queries Search As You Type with a bool prefix match. It issues a bool prefix query against the Search As You Type field to let Elasticsearch match the typed prefix against several internal subfields. The snippet shows constructing the query with the same user input we used before, so you can compare results directly. Under the hood, Search As You Type has stored variants of the text at different token lengths. So the bool prefix can match whole token prefixes, as well as position-aware variations. Changing how aggressive you are with prefix matching, or which subfields you query, will change recall and ranking. Finally, we'll combine both signals so the system can prefer one style, but fall back to the other when useful. This snippet blends both queries via Elasticsearch dismax. It builds a dismax query that contains the Edge Ngram query and the Search As You Type query as separate clauses, and lets Elasticsearch choose the highest scoring clause while optionally adding a small tiebreaker to reward documents that match both. The snippet demonstrates sending that query and observing the order of return suggestions. The practical knobs here are the boost weights and the tiebreaker. Increasing the boost for one clause makes that field dominate results. Raising the tiebreaker makes documents that match both clauses rank higher. This is how you combine breadth from Ngrams with precision from Search As You Type. If you move this toy into production, map the example to real data by replacing the toy names with your product catalog or usernames, and run the same queries on a representative sample so you can measure latency and quality. Recap what it is: 2 ways to handle autocomplete inside Elasticsearch: Edge Ngrams and Search As You Type, each stored and queried a little differently. When to use it: use Edge Ngrams for very short prefix work and raw speed. Use Search As You Type for cleaner multi-word handling and better ordering. One caveat: Edge Ngrams increase index size and can overmatch, so tuning matters. Next step: tune the Ngram sizes and the dismax tiebreaker weight on a held-out validation set, so you can pick the sweet spot between recall and precision. If short, practical IR helps, subscribe and watch the IR videos.